Okay, now we're getting into Chapter 9, and we're going to look at hypothesis testing with just one sample. So we need to go over a couple of definitions for this section. A hypothesis is a claim or a statement about a property of a parameter, and the two parameters we're going to look at most of the time are a proportion or a mean. A hypothesis test, we're going to test a claim about one of these parameters to see if it's true or not. Now the null hypothesis, which is h sub 0, that is always going to have an equal sign. But it's a statement that the value of the population parameter is equal to some claim value. So it will always have an equal sign somewhere. The alternative hypothesis, which could be h sub 1 or h sub little a or h sub big A, that is not going to have an equal sign. It's going to be less than, greater than, or not equal to. Okay, your significance level, that is always going to be alpha. That's the probability of making the mistake of rejecting h sub 0 when it is true. The three most common ones for your significance level are 0, or 0.05, 0.10, and 0.01. Those are the three most common. So you are interested in making an inference about how the value of the parameter relates to a specific numerical value. Is it less than, equal to, or greater than this specific number that we'll have in each example? If we had alpha is 0.05, well, that indicates a 5% risk of concluding that a difference exists when there is no difference at all. Okay, so our null hypothesis is either going to be equal to, or it could be greater than or equal to, less than or equal to. So it's got an equal sign somewhere. Whereas your null hypothesis will not ever have an equal sign anywhere. Okay, here we go. This is the procedure that we're going to need to follow. Notice there are 8 steps. Okay, the step 1 is state the original claim in symbolic form. State the opposite of the original in symbolic form. From step 1 and step 2, identify the null and the alternative. And remember, the null always has the equal sign. The alternative never has the equal sign. Step 4 is just state what the level of significance is, and this is going to be given to you. We're going to calculate a test statistic, and depending on if we are looking at proportion or mean, then our test statistic would be different. So for proportion, it would be a z-score. For the mean, where sigma is unknown, that's usually the case. We don't know what sigma is. We're going to use a t-score. The t-score is a value used in making a decision about h sub 0. Do we reject it or do we fail to reject it? Okay, and then we've got 2 methods we could use. We could either use a p-value method or the traditional method. Okay, so for the p-value method, you're going to find a p-value using a z-score table or a student t-distribution table. You will always compare the p-value with the level of significance. Remember, that's just alpha. And if the p-value is less than or equal to alpha, reject h sub 0. If the p-value is greater than alpha, fail to reject h sub 0. So this is how I remember it. If the p-value is low, the null must go. So we would reject it. So see here, the p-value is less than or even equal to alpha. So if the p-value is lower than alpha or equal to, the null must go, or we reject h sub 0. If the p-value is high, the null must fly. So if the p-value is greater than or higher than alpha, then we're going to fail to reject h sub 0, or we're going to keep h sub 0. Okay, that's using the p-value method. Okay, the traditional method, so we're going to draw a bell-shaped curve, and we're going to locate the area of the level of significance, and we're going to see if the test statistic falls within the critical region, we'll reject h sub 0. If the test statistic is outside the critical region, we'll fail to reject h sub 0. Number 7 is saying, what did you find from either the p-value method or the traditional method? Did you reject h sub 0, or did you fail to reject h sub 0? And then the last thing, number 8, is putting everything back into English so everybody can understand what's going on. Okay. So you will get all the steps except for you will not see this part right here. That will be gone. This part right here, that will be gone. And this part right here. Those are the things that you need to commit to memory for the exam. Okay, now let's just start slow, and we'll take steps 1, 2, and 3. It says, for the given claim, express the original claim in symbolic form and identify the null and the alternative hypothesis. Okay, so here's our claim. The mean weight of beauty pageant winners is 118 pounds. A study of 22 randomly selected beauty pageant results in a mean winner weight of 117 pounds. Okay? So your claim is a claim or a statement about the property of a population. Okay, so we're dealing with parameters here. Since we are looking at the mean weight, I'm not going to use X bar because that's from a sample. We're talking about the population, so I need to use a parameter. So that would be mu. So here's our claim. Mu, and it is 118, so it's equal to 118 pounds. Okay, this is step 1. State the original claim in symbolic form. Step 2, state the opposite of the original in symbolic form. Okay, well the opposite of equal is not equal to 118. That's step 2. Step 3 says from the first 2 steps, identify the null and the alternative. Remember, the null will always have the equal sign. The alternative will not have the equal sign. Okay, so h sub 0. Well, there's an equal sign right there. Mu is equal to 118. That's got to be my null hypothesis. And my alternative hypothesis, h sub 1, that would be mu is not equal to 118. So these two, this is step 3. So notice I didn't even need this part right here to get steps 1 through 3. And that's it. Okay, for the given claim, we're going to do the exact same thing. We're going to express the original and the opposite in symbolic form, and then we'll find h sub 0 and h sub 1. The claim is high school teachers have incomes with a standard deviation, okay, standard deviation, that is more than 20,500. A recent study of 148 high school teacher incomes show a standard deviation of 23,500. Okay, so my claim is about standard deviation. Remember, I've got to put it in a parameter, so I need the population standard deviation, or sigma, is more than, okay, greater than 20,500. That is step one. The opposite of that, okay, the opposite of greater than is less than or equal to, because I have to have an equal sign somewhere, because that's going to be my null hypothesis. 20,500. Okay, so h sub 0 will be the one that contains the equal sign, so sigma is less than or equal to 20,500, and h sub 1 will be sigma is greater than 20,500. Okay. Now, which one of these, h sub 0 or h sub 1, was the original claim? Well, the original claim is sigma is greater than 20,500. My h sub 1 is the sigma is greater than 20,500. So this is my original claim right here. That's going to help us in later steps. If we went back to this one, well, which one of these, the null or the alternative, was my original claim? Well, my original claim was mu was equal to 118. So my null is equal to 118. So this was my original claim. Notice how it can switch, the claim can switch between the null and the alternative. It doesn't have to be one or the other all the time. Okay, last one. Do the same thing. Our claim is at least 24% of internet users pay bills online. A recent study of 368 internet users indicated that 28% of their bills, they pay their bills online. Okay, just like the last one, I didn't need this last sentence for steps 1 through 3. So I don't need this last sentence for just doing steps 1 through 3. Okay, so my claim says at least 24%. Remember, percent, you could say that that is probability times 100%, or you could say it's a proportion times 100%. So really, we're talking about a proportion. The population proportion is represented by P. Sample proportion is represented by P hat. Okay, so I need to write P and is at least 24%. So that would be greater than or equal to 0.24. So I'm going to get it out of that percentage. The opposite of that, P is less than 0.24. So h sub 0 would be the one with the equal sign. So P is greater than or equal to 0.24. And h sub 1 would be P is less than 0.24. And that's it.